And what I'd like to do today is just talk about artificial light at night, because it's something that's increasingly becoming well known as a stressor, an environmental stressor in our system, and yet many of us don't really know that much about it. So I'll be talking about, most of the work I'll be talking about will be from my lab, but it will be my students that have done them, and I'll acknowledge them at the end. I live vicariously through a wonderful group of people that I work with within my lab. So before we can, oh, no, we can't, because this is not working at all. Let's try and see if this works. There we go. Before we can talk about light at night, though, what we need to do is actually think about why light is important. We all know that light's important. We know the sun rises every day and it sets at night, or the earth goes into the shadow of the sun. And light has been a constancy for life on this planet since it began about 4 billion years ago. Light drives patterns of seasonality. Now, I've taken the liberty of using mostly European photos here. I apologise for that, but it does show very beautifully some of the changing seasons, the onset of reproduction and breeding, you can see in the bottom corner down here, and some differences in fur colour that we see from animals in their spring and their winter plumage. Most of these things are driven by light and its effect on hormones. But light doesn't just change things over the annual time period. It, of course, changes it on a daily basis. Light is integral to our circadian rhythm. Circadian is about the day. So if you're a diurnal species like we are, we're kind of, what is it, 7:30, we're all kind of getting to the point where we'll be thinking about going to bed. If you're a nocturnal species, as the sun goes down, of course, that's when you start your activity. So diurnal and nocturnal species are also driven by patterns of light. But light also changes at night. We often think of the night as being darkness, but of course it's not. We have a lunar cycle. Sometimes it is quite dark at night, but when it's a full moon, it's quite different. We can read by the light of a full moon. We can definitely read in Melbourne because we have lights everywhere, but you can read by the light of a full moon. And we also know that animals and plants as well change patterns of behaviour or some of their physiology in relation to the full moon. All of the animals that you can see here do different things under a full moon compared to when it's really dark. So the top two, the species that are usually prey, like the scorpion and this mouse, hide on a full moon. But species that are predators of those prey, like the bird species here, will actually come out on a full moon because it can be more visible and they can try and find their prey more easily. Here we have one of the greatest mass spawning or reproductive events on the planet, and it's driven by a full moon. It's full moon roughly a couple of weeks in October, when all the coral on the barrier reef releases its reproductive material, and we see the birth of new life. On the bottom left here, I put a species that's iconic for all of us. We will all have heard of them. This is the willy wagtail. The willy wagtail you see during the day, but many of you won't know that it actually comes out at night too. During the breeding season, willy wagtails are prolific nocturnal singers. Not both of the sexes, but males. Males will sit on a songpost. Now, if I can put my thing here, and then a gap, and then, which would have been a willy wagtail, which is a male willy wagtail sitting on a songpost under the full moon, and another willy wagtail, a rival male, responding to them. It's really beautiful. I haven't done any justice at all. The point of all of that was that males only do this on moonlit nights, really full moon nights. And the reason for that is they're quite a visual species. And so they do it to advertise themselves during the breeding season. They're doing it to attract females. And the other male is responding because they're basically rivals competing for females. They're doing this to increase their reproductive success. And this work has been done by my student Ashton Dickerson, who you can see up in the top right-hand corner. She's literally just finished her PhD. Very exciting. Now, I definitely don't want to do that. What's interesting about the lunar cycle is that more than 28% of vertebrates and considerably more than half of invertebrates are actually nocturnal. They spend their active periods during the night, and that's really important. And it's really important because that's where light comes in, and this variation in light is really important. But when we think about light, I've just given you lots of examples of the terrestrial light hitting. But in fact, life on Earth evolved, of course, in the oceans. And so we need to think about light hitting the ocean. And when we do that, what we can see, so this is the image of different colours of light penetrating through the ocean. What this is showing is how far different colours of light go down. And what you can see is that blue light down here tends to go down quite far. Now, many of you will have heard about the dangers of blue light and how terrible it is, and we'll switch our phones from blue to red at night. This is why. 4 billion years ago, when life first evolved on the planet, it evolved in the oceans, and blue light was a really good signal of when it was day and when it was night, because it goes down to 200 meters. And so when it's daytime, blue light goes down quite far. Obviously, as the sun passes, or we pass into the shadow of the sun, that blue light wanes. Okay, so it waxes and wanes. And so blue light became a signal for darkness and signal for daytime in the animal kingdom, and indeed the plant kingdom. Even today, plankton moves up and down in the oceans in response to this change in light. And we have the throwback to 4 billion years of evolution. This is, I'm not going to show many graphs, but I will show you this one because it does align with something I'm going to say at the end. So these are wavelengths of light that we can see as humans. The V line that you see here is our visual spectrum. So how well we see different colours of light. And so we see pretty well in the green, we can see in the red, we can see into the purple, but we can't see into the ultraviolet. The C curve that you can see though is another curve that we have. And again, it's our sensitivity, but these are non-visual pigments that we also have in our eyes. So these are perceiving light. They're not giving a visual image, but what they're doing is translating that into a biological signal. And if you look at this C peaks around about 450 to 480 nanometers, which is blue light. Okay, so again, this is why we change our phones from blue to red at night. Now, of course, it can't work on its own, so light needs something. And the key chemical that drives part of this process is melatonin. There's some chemical that many of you have probably heard of before. Melatonin is involved in our day-night rhythm, our own circadian cycle. Now, if you look at this graphic at the bottom, what I'm showing here is how melatonin is circulating in our bodies. Right now, the sun is going down, and so our melatonin levels, this blue line here, is starting to rise, and they peak at night. That's when melatonin production is at its highest. But light stops melatonin production. So light actually stops a key part of the pathway. So in the daytime, our melatonin levels decline, and we're awake. We're a diurnal species. So this is very nicely patterning our day-night cycle. So the circadian rhythm, or our circadian cycle, is one of the things that melatonin is best known for. And it's governed entirely by the presence of light. Now, many of you, or some of you at least, may have taken melatonin to cover from jet lag. You may take it because it helps you sync that cycle better when you go overseas. Because of course, when you go overseas, your body thinks you're in Australia. Then I go to the UK, it takes me about 5-6 days to get back into a normal sleep cycle. Now, whether it actually works, debatable, but it is a really nice segue into another good action that melatonin has, or function, and that's as an antioxidant. So when life first evolved on the planet, melatonin was a chemical. It's often referred to as the ancient signal of darkness. And it's present across all life forms, from unicellular bacteria all the way through to plants, algae, invertebrates like insects, and vertebrates like ourselves. And melatonin is part of the physiology in our bodies that helps control our day-night rhythm, but also acts as an antioxidant, so protecting us from some of the cellular damage that we have. And so it was for 4 billion years. But then, of course, Thomas Edison introduced the electric light bulb. Every single light that was placed into a household had what came attached with this particular sticker. This room is equipped with Edison electric light. Do not attempt to light with match. Remember, they were gas lights before this. Simply turn key on wall by the door. This is why we turn on and off the lights rather than flick them on and off. When we first had lights, they were actually, you turned a key to turn them on and off. What I want you to also look at, though, is the bottom. The use of electricity for lighting is in no way harmful to health, nor indeed does it affect the soundness of sleep. Now, that may be true in some points, but the light that came with it, absolutely, we now know, is problematic. And the reason it's problematic is that light is light. So that beautiful cycle that I've been talking about, the melatonin cycle that's gone for 4 billion years, is disrupted by light. And artificial light at night does exactly the same thing as natural light. It stops the melatonin cycle. So stops the melatonin cycle. We have lower concentrations of melatonin. That messes up our day-night rhythm and it interferes with our physiology. And now this is what the world at night looks like. Now, I don't think Edison really, well, I think Edison appreciated the importance of light at night. He says, we'll make electricity so cheap that only the rich will burn tallow candles. But I don't think he would have imagined that sort of 150, 180 years after his death, the world at night would look like this. So for those of you that haven't seen this image before, it's a composite satellite image of light at night. The darker red, the more intense the light during the nighttime. Now you can see that Europe, North America, some places in Asia is horrendous. Australia is not so bad, but even we have our dark spots. You can pick out every single city, you can pick out gas flares, and sometimes you can pick out wildfires, which obviously aren't artificial light, but they're still there. Nearly 20% of landmass is now covered at night by artificial light at night, and it's increasing rapidly, up to about 6% a year. So here we have Fed Square in the centre, and you can see that this is a beautiful, kind of a beautiful orange light. I say that somewhat ironically, but it's not an unusual city. The picture at the bottom, I'm not actually sure what city it is, but it does show something else that's happening, is that we're changing from that orange light to a white light. That has implications I'm going to talk about at the end. But our sports fields have big white lighting. Here's this Gillen Oval, if any of you live in the Brunswick region. This is where my kids play footy at night, and I put the full moon in the background just as a comparison. So light in the environment is having a massive impact. So we're now at the situation where we have what is called light pollution. Sorry. So light pollution is the excessive, misdirected or obtrusive artificial light in the environment. This is my local area and all the different types of light that we have. I'm just going to want to mute for 1 second because sorry. So you can see security lights, you can see the sports lights that I was talking about. Over here you can see car lights. Someone on their balcony has got, you know, pretty lights that they had at Christmas. They did put them up at Christmas and just left them then for the year. So light comes in many forms, and it really is everywhere. Oh, very annoying on two screens, Nick, actually. I just realised because you move it and it doesn't move. And it's not just the city environment, though. We know that lights permeate all different environments. So these are some images. Thank you, Monica, for one of the images you sent through of light at night on Merri Creek. We now have lights in our parklands. We use them because we move around and we like to be active, but they inhabit and they encroach upon so many different areas now. And light masks the transition between day and night. It doesn't really create a daytime at night, but what it does is creates kind of like a constant sunset or sunrise. And light pollution has ecological consequences. So let's make no mistake, light is there because it disrupts movement and activity. We put it there because as humans, that's what we want to do. We want to be more active at night, but we also know that it impacts lots of other animals as well, like bats and turtles and other mammals. And it masks that sunrise and sunset. That willy wagtail that I just told you about that's sitting on that signpost, in light at night areas where there's lots of exposure, it masks its behaviour. It no longer does the same behaviour under a full moon. It masks that lunar cycle. And so light at night is attracting lots of species, things like this moth. And a single moth is quite beautiful, but what if it's tens of moths or hundreds of them? What if it's thousands? What if it's whole communities that are being disrupted? And they're not just being attracted, they're actually being trapped in these lights. So we know that animals become so disoriented that they don't leave the light environment. They become like deer in headlights. So these spots that you can see are bats and birds and insects trapped in these environments. They're what we call ecological traps. Now, light, I've always been told not to make everything too negative. So this is my positive slide out of all of them. Light at night can benefit because there are species that feed on the insects that are aggregating around lights, like geckos or spiders or bats. But potentially there are physiological implications for them doing that, even though they're gaining foraging benefits. And so one of the physiological implications we know is that light can potentially affect health. Remember I said it was a powerful antioxidant. And if you knock that away, then it can lead to health implications. All of the animals on the top that you can see have been shown to have repressed immune function if they're exposed to light at night. In humans, the World Health Organization and the American Medical Association have both declared light at night potentially carcinogenic, and blue light in particular really bad. So it's disruptive for these groups, night shift workers in particular. And we know that light affects sleep and circadian rhythm. If you stare at your computer at night, it is going to be much more difficult to go to sleep. We know that children are particularly affected by blue light as well. So red filters are really important. This is my phone, it goes into the red at night. My kids think it's horrendous, but that's what they do. And we did some work looking to see whether it would work for birds. These are two of my colleagues at La Trobe Uni under an amber light. So we tested this, could we throw amber lights into the environment to make a difference? We found that for swans, the black swan down in Albert Park, we did this, we translocated them to Serendip Sanctuary. And there we found it didn't matter whether we put a white light or an amber light, they were still disrupted in terms of their sleep. So the street lights that we have are potentially disrupting not just our own sleep, but that of the animals around us. We repeated the experiment on pigeons. This is Anna Ulsbrook and Farley Connolly. We found pigeons, it was the same thing. Magpies were slightly different though. In magpies, what we did is we put amber light into their environment and white light, but we turned it off late at night, kind of like turning streetlights off about midnight to see whether they go back to sleep. What we found is that under the white light, they didn't sleep as well. Amber light was much better for magpies, even though it had no impact at all on pigeons. But what was also interesting is when we turned it off, they rapidly went back to sleep. So it's potentially a mitigation method that we could be using. And it's suggesting that those lights in the environment not having an impact on physiology, but rather increasing the visual environment for those birds, potentially making them more nervous about being in the environment. Light pollution, though, is also now implicated not just at the level of the individual, but in terms of biodiversity. There are declines both in terms of vertebrates and invertebrates that have been linked to the presence of night lighting. We did a study in Moorland, so I'm mentioning lots of suburbs here, but we did a study in Moorland where we replicated something they'd done in Europe, and we actually trapped not birds this time, but insects. So we trapped them. You can see the little light traps we have here. These are pitfall and aerial traps. So the ground dwelling animals fall into a pitfall trap. Aerial insects in particular slam into the aerial trap, and we can capture them. We can look to see changes in abundance and also the community of these animals. And we did it under lights and between lights. So here you can see a trap under a light, and you can just about see the one over here in semi-darkness in between lights. Now, what we found is that there was no difference in these traps in the daytime. So whether a trap was between a light or under a light, the total number of vertebrates was the same. But if we had traps at night, what we found is that those traps underneath the street lamps were attracting the insects in. There were a greater number of insects or invertebrates going to those traps. What we're actually doing and what we're seeing is that light is trapping these invertebrates. Now, does this matter? There are lots of them. Potentially it does, because it can potentially affect the whole health of the ecosystem. So again, I'm putting Merri Creek here and just showing you an example of what might happen, because there's been a lovely paper on this recently, looking at what might happen in a river system if you put lights into that environment. What the lights are doing, this light, for example, here, can attract those insects into the lights. Because they're trapping them there, they may escape, or they may fall down into the ground. What you then get is a cascading effect where you get changes in community composition. So insects are emerging and potentially attracted to lights, then predators and scavengers. Obviously, it's a brilliant thing to just hang around the lights underneath, because then you get fed more. But it can change that community. And we see spiders, for example, extending their activity, nocturnal spiders extending activity into the day. So you're changing the whole community and ecosystem with the presence of a light that ostensibly shouldn't really be there. So what about the future? The problem is that mitigation measures are conflicted with humans, because we quite like light. In fact, humans are rather drawn to lights. All of us are in our rooms at the moment. We're not sitting in darkness. We've all got lights on because the sun is going down. And some people think that, lighting up your home is beautiful. There are certainly going to be animals that are going to do okay, and people have them for security. But if you look at this picture on the right-hand side, what you can see is it's quite glary, and what you would do naturally is hold your hand up like this. And if you do that, what you'll see is that the glare of the light has actually obstructed your view. Okay. So some of the things that we have, or the mitigation that we are having to consider now, is considering human ideals. Recent evidence suggests that actually more lighting alone doesn't create safer cities, but we can be careful with our lighting. We can create lighting and make it more appropriate for the environment and more appropriate for the ecology. I introduced that picture at the start. One of the issues we have at the moment is that we're also changing the colour of our light. This is what we used to have, this orange lighting on the left-hand side, and here's a spectrogram. So this is the colour of light coming off. What we now tend to see, and many of you will know this if you're in the Merri Creek area, is that you've seen a massive shift to LED lighting, and now it's quite blue, and a peak looks like this. And this overlaps now completely with our own circadian peak. So the lights that we're putting out align perfectly with our own sensitivity and melatonin. There is positives from this, though, that we now have national light pollution guidelines which raise awareness and give wildlife a voice. There are risk assessments and environmental assessment processes within them. And at the moment, they're on a couple of species, but that's expanding, which is great. We also have the International Dark Sky Association, and we have dark skies, and we're very fortunate in Australia that we have a number of them, and they are beautiful. If anyone's ever been to the Royal Mungals, then you probably have been to this park, and it is outstanding. I'm also, as Nick said at the start, part of the Australasian Dark Sky Alliance. So it's a volunteer organisation, and we're really trying to educate the public and policymakers. I've given probably 10 talks in the last year talking to government and industry about this. And there are situations where we can improve it. We can turn lights off. In California, the turtles are saved because they turn all the lights off on beaches. The turtles no longer head inland, they head back to the oceans. So they're trying to instigate measures to protect. So ultimately, in terms of light, it is potentially problematic. It has changed 4 billion years of evolution, but there are things that we can do. And what I've realised is one of the things we can do is to bring back the night sky and try and see the beautiful Milky Way and some of the things that we have as part of our Australian landscapes. The first thing to do is eliminate, so turn off lights when and where we can. Of course, that's what we should do. But if we can't do that, we should mitigate. So dim lights or shield lights, make sure they face down, they're not glaring all over the place. We can try and change the colour of lights, make them more amber and get rid of that blue, although that's problematic because obviously we know that it doesn't work for all species. But what's really important, this is where I come in, is really trying to understand the impact. We can't really know what problems we're facing if we don't have an assessment of what was there in the first place. So with that, I'd just like to thank my students who do all of the work and have worked on a range of different aspects of urban light pollution, from oxidative stress and immunity all the way through to circadian rhythm and community level impacts. I'd also like to thank the Australian Research Council, Herman Slade Foundation and the Holsworth and BirdLife Australia for funding my research. So please turn off the lights, not right now obviously, but just a bit later on today. But when you do, remember that the reason we're doing this and the reason we shift our phones is because 4 billion years ago, light was an important trigger for life in the oceans to distinguish between day and night. And it's this trigger that's driving some of our behaviours today. Thank you.